Today's lesson is on Lewis dot diagrams for neutral elements. A Lewis dot diagram consists of a symbol, I'm going to use the neutral, like the generic X here, as well as a series of dots around the outside of it in a specific order that are meant to represent the number of valence electrons that a particular element has. That order is this. So we're going to put the first valence electron here, the second one here, the third one here, and so forth. Okay, now it does not matter really where you start. What matters is the pattern. If I wanted to start here, then my second one would be here, and so forth. Okay, so let's just take a look at a few examples. Lithium, Li, is in family 1A. It has one valence electron, so I'm going to draw one electron in the 1 spot. Okay, it doesn't have to be here. I could put it here. I would not change anything. All right. Now, let's take a look at something like nitrogen. Nitrogen has 5 valence electrons. So when I place them, I'm going to place them around nitrogen like this. Now, again, it doesn't really matter where you start. What matters is the pattern of moving around. If I wanted to start with nitrogen here, 1, 2, 3, 4, 5, you're going to see that the general setup is the same. Right? There's still 3 sides that have single electrons and 1 side with a pair. It doesn't matter which side that is, however. Right? Let's just do 3 more examples to see if you really fully understand. Why don't you try to draw the Lewis dot diagram for the element fluorine in family 7A? You are correct. Fluorine's going to look like this. We will have an electron in every spot except for that 8th spot. Now, what about magnesium? Correct. Magnesium looks like this. And it is important that it looks like this. It doesn't have to look exactly like this. So what does like this mean? What like this means is that we have 1 electron that's by itself, and on the next side I have another electron that's by itself. Right? That could look like this. That could look like this. That could look like this. It could not look like this. We have to stick to this pattern. Okay? Now, instead of telling you element and then asking you to figure out what its electron configuration is, instead I'm going to give you a few and I want you to try to figure out what the mistake is. Here, gallium. It's in family 3A. It has 3 valence electrons. But if you saw this, what would the error be? That's correct. We need to move around in this pattern. Gallium should look like this. Here, this is a depiction of oxygen. It has 6 valence electrons. This one has 6 valence electrons, but what's the issue? You're right. Oxygen should look like this. And while it might seem trivial now, I promise you that this setup and this order will become incredibly important when we start to draw covalent molecules. Until then, happy Lewis dotting.